My name is Andrey, and today my speech will be about more procedural aspects of involving testing into CI. I will less focus on Taurus Tool, and those of you who saw our small booth demos are probably know the Taurus Tool, something about it. I will speak more about which aspects of the process are involved and which are the challenges of the testing inside continuous integration, how to start with that and how to proceed. A couple of words about general CI thing. Nobody argues anymore that this is the fact of practice, and important aspect of CI is that machine time costs nothing today. So human time priceless. We prefer to shift as much of dumb work onto machines as possible. Sometimes it's even non-trivial, but still automatable work, and leave the creative work for humans. And this is our general direction. We want to maximize that time and only make humans make decisions which are creative and cannot be done by humans. And with deeper and deeper analysis, we understand that more and more decisions might be made by machines automatically because the factors are pretty much formal. And with the proper tooling, we can do that automatically in a lot of cases and leave humans without repetitive and tedious jobs. Most advanced teams goes to the extreme, and they go with continuous delivery practice when they literally deploy after the commit, the code is being deployed into production. Sometimes it happens because they want really, really fast delivery pipeline and to not delay these commits and not pile them before release. They want the value to go directly into production. Or sometimes companies go with CD just because they have too many assets, too many projects, like 5,000 websites. You cannot go with manual deployment of 5,000 websites anymore. Otherwise, you would need 5,000 release managers to do that, or like 1,000 of release managers to do that properly. Instead, you go with automated processes and you set the rules to not fail on this way. A lot of teams still in process of adopting CI, CD, and machines because it's not because they are not aware, it's just because they evolving from the past, and in the past the CI was not as common as it is now. So we need to help these teams to do their first steps and adopt CI, maybe not always in the idealistic way, but more in practical way. Today's agenda, I will speak about, in general overview, which things we do take from humans and put into continuous integration machines. The best practice is the overall goal, overall direction, how you should set it, where you should go, and challenges on that way, and the ways to overcome those challenges, and in particular, why you should use Jenkins as implementation for that, and which aspects of Jenkins will you help in adopting CI and testing inside CI. Things we put into continuous integrations. First is we put there the logic when to do the action. It's not like, hey, Bob, I have committed the code, now take this code and build. Bob is release manager. Not like that. It's automated way to go without a human and check out the latest source code, see the change, or do this nightly, or whatever. This is important part of CI process. It's a question when. On event, on scheduler, maybe manually on the button, but even the button is better than just human doing it manually. We take version control checkout step as natural step for continuous integration, and dependencies is less trivial thing. Sometimes we need to pull a lot of, I don't know, PHP Composer things, components, Node.js checkouts. This is also important part of the step, might take time and might fail. Building and compiling project, today it's frequently not compiling the code into binaries, but more of building from templates, again, Node.js applications, which involve, I don't know, less templates processing. Many frameworks allow these days some of their own formats and building process for that. And we put on this triggering and preparation stage, we put some of the intermediary artifacts into storages, into repositories for the future use on the later stages, or maybe as the final artifacts for the future. Next thing that we put there is the quality control. This is the main topic of us. This is where the testing happens. We put static quality control, static code analysis there to calculate some of KPIs, and modern systems and modern tools helps us even to spot some typical issues and bugs in the code just by statically analyzing the code without compilations, without running it. Unit tests is trivial thing. This is natural beginning of continuous integration. This is how it started. Functional tests becomes more challenging. Performance tests even more challenging to put into CI, but we still might want and we should want to put it there because machine time costs nothing, human time is priceless. We should make machine to do these tests, not human. And these two, they need deployment. This is the problem of functional and performance tests. You can do unit tests on the machine, on the continuous integration machine itself. It's tough to do functional or performance tests completely relying on the continuous integration machine. You need some kind of environment. It might be containers within that machine, but it's still the environment. You need databases, whatever. This is the challenge on functional and performance tests within CI cycle. This is where you should pay your attention to and see the challenges and solve them, where you should expect those challenges. The deployment stage is when you proceed to continuous delivery, maybe not to extreme continuous delivery to the real production, but to QA environment. This is good. You have further manual tests. You still might not have functional or regression tests yet because the feature is really, really new. But deploying, helping, again, taking off humans, the deployment stage and putting it onto machine is a great help. Staging environment means that you about to deploy it into production and you will do the user acceptance tests there. Another great win to have it automated. And production environment, well, this is our future dream, but I know companies which go exactly that way because of that 5,000 web assets problem, and they cannot afford and cannot budget 1,000 release managers for that. The best practice, this will be our idealistic future, and it's not as far from now. This is something that Jenkins does right now with the pipeline plugin. I will explain it in a detail. The idealistic way that I know is one-way road, and this road is driverless. We all heard of driverless cars, so this is the future. When the car moves one-way road, no challenges, no risks of having crashes, just go one way. And this is the pipeline of continuous integration. You have the step and you have the filter. You have some check that says, if I fail this step, we interrupt the whole drive, and the only way to start again is to start from the very beginning. You build the software. If it failed, you cannot proceed. You cannot fix and proceed. This is the one-way road. You cannot go one step back. You cannot start in the middle. You just go, do as many steps as you can, minding the filters on your way. And if you fail, the only way to start from the beginning. This is more mindset way, but it goes out of practice of branching, intensive branching and merging, complicated teamwork on the code base, because your team might do these pushes into pipeline together with you, and these pushes might be changing the rules of the future pushes by you. So you cannot control, you cannot do something in the middle of the loop because there are others going that way. So you have to build it as a conveyor style. Throw it into beginning of conveyor, look how far it will go. Hopefully it will get to deployment, to the final deployment stage. And on that way, if you can parallelize things that happening regarding functional and performance tests, you cannot, and you can technically, but you shouldn't skip or parallelize the unit test step because this is the general consistency filter. You shouldn't do it in parallel with others. It should be the preceding check. This is general mindset of the pipeline. This is the nature of Jenkins pipeline vision. And this is how I've proven for myself on practice that this is the way to go. It simplifies the life for everyone because the rule is really, really simple. One-way road rule is very simple. Two-way road is not as simplistic. So this is the natural evolution of CI systems. It simplifies the things that when you work with pull requests or branching, because each of the branches have its own pipelines and it leaves its own one-way roads in continuous integrations, and you don't put all of the branches into the same pipeline. This will cause the problems. Jenkins 2.0 introduced and promotes the concept of pipelines through the Jenkins files, through its pipeline plugin and multi-branch pipeline jobs a lot. So pay attention to these plugins, these new things that now becoming the common practice. I can say, well, Travis CI was like first maybe beginner of these concepts being offered to the community, but Travis CI is very, very limited in functionality. So Jenkins did the right step, it took the right practice and merged it into its feature-rich environment of Jenkins jobs and plugins, and generally it allows you to install it on your own, which Travis CI cannot give you. So Jenkins goes the right way in the evolution of the tools. And we present the Taurus tool as part of the concept that supports this one-way road, and it plays well with Jenkins to allow you to simplify the life for you when you're debugging these kind of one-way road jobs. Let's see the challenges that you face when you try to put functional and performance tests into CI cycle. First challenge is the test environment, that deployment requirement. Modern applications are complex. It's not LAMP server anymore. You cannot just spin it up within a single machine as easy anymore. You need different storages. You might need CDNs. You have third-party APIs. And your application consists from many layers. This is our modern reality. It's not like 10 years ago anymore. It's all become complicated. In general, functional and even more performance tests are time-consuming. But we remember the idealistic requirement of CI cycle. It should be within 10 minutes. Well, okay, today it's more like 30 minutes. But 1 hour is not, you're not continuous. If your CI cycle more than 1 hour, even 30 minutes is painful. But if we say that we need continuous testing, continuous control, humanless process, we need to somehow take all of these time-consuming things and put them within that 10-minute, okay, 30-minute cycle. We have many functional tests. This is what causes them to run long, and performance tests are naturally long and running for hours. Another challenge is the problem, this is process problem of debugging CI jobs. When you start putting everything into machine, obviously there will be some problems raising and failing jobs because of the job problems, not because of the software failed or the test failed, but the job needs to be improved. And this is the problem, how to debug that when you put it into CI machine. You don't want, like on the right there is example, like first build failed, number 27, and then people spend three more builds to actually debug and figure out the right job setup to fix it. There was no software problem, there was no failing test. Just because job was failing, you need to maintain the job itself. And this is not something that you want to have inside your CI cycle. If the job has failed, you should be able to minimize effect of failures and don't debug it like your CI is kind of your production release management system. You don't want to debug there. You want to take it out of CI machine and debug it, make sure it works, and put it back into CI machine. Why? Why do you need so? Because when you become continuous, when you run that inside CI machine, your build history becomes a value for you. You start tracking your trends, my lines of code trends, my unit tests, failures trends, and you start gathering important health information about your project and your process. The predictability of your process derived from these KPIs. So you don't want to spoil this history with debugging trial executions. You want rather have it clean. Okay, we failed, and then we fixed the fail. Not we were fixing and fixing and fixing. This is not the right picture to show to your management. This is not the right way to do it. And fourth main challenge is that result analysis is difficult within CI machines, just because we have too many technologies, and every technology, every area of the activities that we do around everything that we put into CI has its own purpose-built features, purpose-built tools. And Jenkins, well, it's flexible, but you cannot play all the tricks in the world at once. Jenkins has its limits, has its UI, which you cannot teach Jenkins to show too much things through its UI. It will be just overbloated by features. It makes sense to somehow divide. There is a separate challenge of automated decision making when you go and you chase the continuous delivery. Continuous delivery implies that pretty complex decisions should be made by a machine, and this logic needs, I don't know, some very intelligent Jenkins plugins, and it's complicated. So you need to have purposely built thing for this kind of decision making when you try to go safe with continuous delivery. And another problem is that Jenkins is not generally built to be non-techies friendly. It's engineer tool. You cannot ask your manager, hey, this is the Jenkins, you will go and see the status of the project in Jenkins. What? What's this Jenkins? It all looks like your engineering tool. Where's my executive report? Where's my executive dashboard? And well, Jenkins was built for engineers. This is natural. This is why you have to go out of Jenkins sometimes on the higher level reporting and status reporting things. Natural challenge. How to shortly overcome these challenges in practice? First thing is containers will help you with test environment deployment. This is the lightweight way for you to deploy. And second thing, you don't have to be as realistic with your testing environments. In practice, you can stub a lot of third-party APIs for the testing purposes. You can literally replace this lab with like one smart Linux machine, having a couple of Dockers inside. The database can replace you the complicated setup. Don't try to be 100% realistic. Yes, say it openly. Yes, we trade being realistic for the practical price of build time, but you will replace that with comparison and the trend line of the history. It's like my general suggestion is that you don't need the absolute number of, I don't know, 100 milliseconds response time. In CI, you don't need that number. The more interesting question is how much different this number from previous 10 builds. Is it getting better over month? Is it getting worse over a month? Is this kind of 10 times larger than previous build? This is more interesting information, not that I'm reproducing within CI the fully blown production application. So this is how to overcome this challenge. You don't need to be as realistic. The time consumption thing is also doable, and you will need also to trade off between being realistic and between having pure environment at the beginning of the test. Well, you can prepare something upfront, for example, for your load test. You can prepare the data set that you will use for your load test in the night, have another automated job, prepare the huge data set that you will be using across all the day, all the coming day, and in the next night you will prepare another data set based on the production logs. But within the day you will not spend that 30 minutes time frame to generate data set for every test. Reuse what you can. Maybe you can deploy your static assets into CDN once a day, or you can deploy it incrementally, or somehow not try to deploy everything at the same time, every time you run the CI. This is your trade-off. You will need to somehow divide the job, take it out of CI cycle, and make it be prepared upfront. For the performance testing, specifically, I can tell from practice that short tests can reveal a lot of things. And again, this is the trick with performance tests. You don't need to know the absolute number. You need to know the relative number and the trend. Is it getting better? Is it getting worse? How much different is it from my baseline, where baseline can be like last 5 successful builds, or my specific SLA that I have set, or somehow you compare it to some value which may not represent production KPIs, production levels SLAs, but you set your own CI, continuous integration SLAs, and you compare to that. Don't try to make endurance tests. Don't try to make spike tests inside CI job unless you do it on a manual pattern when you just press the button and it makes the test, not continuous test. You can put it for automation purposes into CI, but into Jenkins, it will not be continuous. But you don't need this test. Don't try to make production, pre-production, high-scale acceptance tests for performance into CI. It doesn't work that way. You don't need that for every build. And try to parallelize tests. Jenkins version 2 has the ways to parallelize the builds and steps within the builds. Taurus Tool allows you to simply divide tasks into pieces and run them in parallel, and this will spare you a lot of time. And BlazeMeter in general can give you some resources in the cloud to parallelize your tests in the cloud if you don't have resources in-house. This is your ways to shorten the time of continuous integration cycle, but still have functional tests there inside and performance tests inside. How to overcome debugging in improving. You saw this picture maybe on the booth demos. This is the Taurus tool, and this is our vision on how to solve that problem of debugging inside continuous integration. Just take the debugging out of Jenkins when it failed, have it as Taurus configuration, take it out of Jenkins, debug it locally, and then commit it back into repository, and you will not spoil the history of results in Jenkins, because you will do all the failures on your local machine. And this is the thing. This is handheld piece of CI. You take it out of Jenkins, you modify it, you put it back into Jenkins, it runs there. The same thing, exactly same tool, same engine will run in Jenkins and your local environment. This is the way to have your piece of CI on your laptop. Last thing is how to overcome reporting and result consumption problem. The obvious answer is there are always purposely built services for static analysis, for the artifact storage, for the bug tracking integration, cloud services integration, and you should keep the overview and status inside Jenkins. Again, on my booth demos, I was showing you how I'm keeping the overall trend line inside Jenkins. There will be, I think I will give one more booth demo on BlazeMeter booth specifically showing this. I'm having my simple trend line inside Jenkins to just overview what happens in general. If I need details, I'm jumping into BlazeMeter reporting system and I'm getting tons of reports. I'm getting comparisons, trend lines, easier trend lines. I can change them whenever I want to. If my requirements change, I'm changing the reporting and it reflects the past, which is difficult in Jenkins. Jenkins always reflects the current state. Overcoming decision making, this is a specific aspect to address when you go with continuous delivery, continuous deployments, and deploying to QA or to staging is a great, great win. You already covered very latest stage before actual production deployment. It's okay to have production deployment or staging even deployment as a separate job, because on the staging, on pre-production, you have user acceptance testing going. You don't want to disrupt that process and in the middle of QAs manually testing new feature, deploy them new version. This is not something, well, ideal world says let's do it continuously in automated fashion. It doesn't work like that on practice. You cannot disrupt the system which is being under user acceptance testing, which involves humans. You see, the humans are the problem. Without the humans, it would be just go straight to production. But we need the user acceptance testing. For that, somebody should write those automated scripts. But this is a great win. And separate thing is pass-fail criteria for functional tests are simple, but for performance tests, you need complex pass-fail criteria, because functional tests are easy. Your tests either pass or fail. It's either red or green, and nothing in the middle. In performance tests, it's difficult because it's the curve which goes like this, and who knows where it is bad enough. Did it go high enough, the response time? Did it go high enough to fail? And sometimes these criteria are really complex. For example, it's not response time, but I want to fail it if the CPU on the server has exceeded this certain value. Or on the database, there was too many locks, and I'm failing the build because the lock's exceeding something. It's tricky, it's complicated, but it's possible. For example, Taurus Tool has built-in mechanism for really complex expression of failure criteria. It can take that criteria of CPU, KPI, and saying if my CPU exceeds 80% for consistently 5 minutes, then please stop the test. This is the failure. This is how to overcome these things. Pay special attention to failure criteria. Do you remember one-way road? It has filters on its way. Pass-fail criteria is one of these important filters on the latest stages. And the later you on CI cycle, the more risky it becomes to pass that stage, because you're nearing the deployment. Let's say what specifically Jenkins gives you for performance testing. It's pretty simple. First, why Jenkins for performance testing? Just because testing is multi-step process, testing is long-running process, testing is repetitive process, and Jenkins does it all perfectly. No questions at all. First is start simple. If you don't have Jenkins adopted, or you have team which definitely needs Jenkins to be adopted, you're already using it, you're already the believer, and they are not, you want to convince them. The easiest way I know is to convince them to install Jenkins, have somebody experienced to configure the job inside Jenkins, and put the button onto every job. It's not continuous, it's not automated, but you give them the most pleasant experience. Just go here, press the button, and the thing will happen. And then you have developers, and then you have QAs, and you have operations guys coming and pressing those buttons. Press the button here, and you will have your network saturated with traffic. This is the operations guy dream. He will tune the routers, and he will press the button, tune it again, and see how it goes. You made half of the job for him. And then these guys will come to you and say, hey, I actually would like to tie this to my commits, because it's like, why should I go and press that button? I'm a human. This is stupid action. And this is the reason why this Center of Excellence guy actually gives them that button, because he don't want to press that button. And this is what happens on practice. The QA people frequently they do automation, and then they become the proxy for a button. Hey, Bob, please kick off the test. Okay. And then you realize that you spend all of your day pressing the buttons. Could you do this yourself? Here's the button. Yes, I can. And you're done. You're in CI. You half into CI. And the next natural step is they just say, okay, let's do this nightly. Let's do this per build. And yes, we will need to deal with problems doing that for every build, reducing the times for performance tests, parallelizing things, but there's obvious benefit from using Jenkins for your testing, even without being continuous. When you're becoming continuous, the periodic jobs have many applications for them. You can monitor your production just like 5 hits every 5 minutes to measure the response time and the general health of my production. You can monitor it every hour. You run the critical transaction on production, and you are sure that the functional consistency is still there. It's not testing, it's more monitoring, but it has its applications for Jenkins. You should have valid failure criteria when you move into continuous flow. When you do it per build, then you should have those filter stages. Make sure that you have the checks, that it's not like your unit tests not just running the code, they have assertions in them. And specifically for time-consuming jobs, you can just use non-blocking downstream jobs. This is an easy trick inside Jenkins. You can set one job to do unit tests and trigger the performance test, but don't block the unit test job from finishing and reporting success to developer. And by that, you will allow this kind of flow. This is the full picture how you should do it. Have your developer, let's point it here. Have your developer here to only push into Git repository. And the only way to trigger it is to pull from Git repository by Jenkins. Have the build, all of the easy steps and unit tests being done as the first job. And give the fast feedback for developer that at least on the basic level, his job is fine and he can proceed, maybe improve it. Do not block him. You remember that XKCD comic, like my code is compiling, so you can just like have fun because your code is compiling. Don't do that. Let them work more. Let them produce more code. Because, okay, if unit test passed, just proceed. You will throw more into continuous integration pipeline. You will deal with further diagnostics later. And then have this job to trigger functional test job and load test job in parallel. You may have 5 cycles here and just one large cycle from here. This is okay. This is the trade-off between time-consuming and speed of responsiveness in your process. And yes, in the ideal world, we will deploy at least to staging or maybe to QA, but it's fine, again, to break these steps if you can break them. Not like 5,000 assets case you will not want to break. But it's okay if it's disruptive for your manual testing. You can split this thing and configure your deploy job. I think there is feature for that in Jenkins to be able to run the job only if upstream jobs are successful. So you will be able to run deploy job only if the functional tests, load tests, and unit tests are passing at the moment. There are many things you can do with Jenkins. So this is approximate process picture how you can organize that and have your developers not saying that this your CI thing is not as continuous as you were saying in the beginning, and still having the feedback of the slower stages, and still having the buttons on these stages to kick them off manually, and taking most of Jenkins. Let's quickly go over just like 3 or 4 items which will help you in Jenkins specifically for the performance testing. First of them is the plot plugin. There are some plugins which give you existing reports, but the plot plugin gives you freedom. I know that the variety of KPIs you want to track in your test is so huge that that there's no existing bundle solution which will give you exactly what you want. You always want something more, your own, your specific. So learn to master the plot plugin and build your own graphs. In my booth show, you can come and see how my graphs look like. It's not as complicated to teach Taurus to export CSV files and teach plot plugin to take data from those CSV files and plot me the history of my own KPI, because Taurus, for example, gives you like tens of KPIs, and you don't want to have tens. Well, this screenshot is like messy bunch of lines, and you don't want to have this unclear picture. You want to concentrate on what is important for you. You can have that, use the plot plugin. Next plugin is specifically for JMeter users, more for JMeter users. I think I'm maintaining this plugin, and I think I will put the Taurus integration into it, and Taurus will export some data which this plugin will consume. This is something that gives you not full freedom of the graphs, but you don't need to configure it too much. It's pretty much simple. Just give it a file, it will process the file and give you the reports and the results. This is the plot plugin. There is BlazeMeter Plugin if you want to go with cloud scaled and use the cloud resources when you don't want to have any in-house resources for performance testing, because performance testing requires a lot of load generators to produce moderate load. And to parallelize tests, you would need even more resources. BlazeMeter gives you that, and there is BlazeMeter plugin for that in Jenkins. And last and most interesting, most trendy thing is the Taurus tool. This is not plugin, this is command line tool, and there are reasons for that. The reasons are that Jenkins plugin in general, if you will look into plot plugin, this is the example why Taurus tool is not Jenkins plugin, because when you have a lot of features, the UI of Jenkins becomes really, really tricky to manage. It's complicated, and it's not pleasant to manage complicated jobs inside Jenkins UI. Instead, we offer the command line tool with configuration file, which anyone can understand, which is pretty simple and which has a lot of different angles to use. And you put that, again, my booth demo demonstrates this approach. This is the handheld piece of CI for you. You take those configuration files and you put it here, put it there, take it into CI, take it into any of your own automated systems, and this is how you go. And Taurus tool is built with specific features to interact with Jenkins plugins. The only way to interact with them is to generate artifacts for them. This is the Jenkins approach. And Taurus tool is able to generate specific, like for plot plugin, there is specific way to export data and take it from plot plugin. And this is the integration between Taurus tool and Jenkins plugins. And by using Taurus tool, you get the freedom. It's not JMeter or Gatling. It's not Siege or Selenium anymore. It's use whatever you want, whatever you like, whatever you have adopted already. Or if you're migrating from Gatling into JMeter, and you're in the middle, and half of your team's doing Gatling tests and half of your team's doing JMeter tests, just take Taurus Tool because it's your common vision, common universal plug for all of these kinds of tests, and it plugs it into Jenkins fine. So the final summary of what I was describing is we should have tests inside CI cycle because we want to put as much job as possible off humans and leave it to machines. Machine time costs nothing, human time is priceless. There are ways to start it simple and help teams who hasn't adopted Jenkins and CI machines yet to start doing it. There are tools and plugins to help with that, help parallelize things on your way, mitigate all of the challenges, fight them. And Jenkins 2.0 pipeline plugin and the view of pipeline jobs, one-way road, is the way to go, is the future, and this is how you should organize that. Thank you.